everybody. We're going to look at our morning work for this week. This will be the morning work for May 11th through the 15th, 2020. You can see I'm not at my house this time. I'm actually at Snappy Lunch, which is kind of like my other home in addition to school. So I've got a little paper towel here, but I'm obviously going to sanitize this little space where my whiteboard has been. But anyway, I just wanted to change it up today a little bit. Okay, so number one for Monday says, what is the area of the figure shown below? And then we have this little picture. Remember the area, I'm going to use length times width to find the area. So I'm going to multiply 8 times 2 1/2. When I multiply a mixed number, remember that I have to make it an improper fraction, or I have to do each part, like 2 times 8, the loopy method we called it, and then 1/2 times 8. Or I can just turn it into an improper fraction. So to do that, I would say 2 times 2, which is 4, plus 1, which is 5. And then that's going to go all back over 2. And then to make 8 a fraction, I would put 8 over 1. Okay, so 5 times 8 is 40, my numerator, and 2 times 1 is 2, my denominator. And then that does look a little bit wonky because I have 2 whole numbers I can just divide. So 40 divided by 2, fraction bar means to divide, 40 divided by 2 equals 20. And then in the measurements, I believe they're in centimeters. So I'm going to put centimeters or cm, and it's area, so it's going to go to the second power. When we have volume, that's when we put it to the third power, but it's to the second power. There we go. Monday number 2 says, which shows the sum of 3/4 plus 1/2. So you can use the pictures, or what I did was I just solved it first and then I saw what picture matched that. So I would normally use 4-square method. Since I don't have enough space, I'm actually just going to do it this way, which is the same concept as 4-square. 4 is going to be my common denominator. So if I multiply my numerator and my denominator by 2, 1 times 2 is 2 and 2 times 2 is 4. So basically 1/2 is equivalent to 2/4. I didn't change the amount, I just changed how it's represented, okay? And then I'm going to add that 3 plus 2 is 5, and then 4 stays the same. So I'm looking for an answer that is 5/4, or I can also think of that as 4/4 plus 1/4, or 1 whole plus 1/4. So I'm also looking for 1 and 1/4, whichever way you want to think of it, okay? I don't know how well you can see my shading, but it's also on the document under the task board. So I have 1 whole here, and then that's it. So that's not going to be equal to my answer. This is just 1 whole. Okay? B, I have 1/2 plus 1/4. Okay, well that's not going to equal 5/4 because here I had 1/2 plus 3/4. So that's not going to be equal either. For C, I have 1 and 2/4, or I could simplify and say 1 1/2. So that's closer, a little bit, but it's not quite the same thing as 1 and 1/4. And then for D, I actually have 1 whole plus 1/4, which matches my answer. Okay, I could also think of it 3/4. I have 1, 2, 3/4 plus 2 more fourths. Okay, so your answer is D for that one. Tuesday number 1 says, how many 12-ounce bottles would be needed to hold the same total amount of soda as 48 bottles that each hold 16 ounces? That's quite a wordy question, and it's a 2-step question. And first of all, I need to know how much soda this would be, okay, because it says the same amount as 48 bottles that each hold 16 ounces. So I could add 16 over and over and over, or I'm just going to multiply 48 times 16. That's going to tell me how much liquid I have. So 6 times 8 is 48. 6 times 4, 24, plus 4 is 28. Placeholder. 1 times 8 is 8. 1 times 4 is 4. And then I'm going to add those up. I get 768, okay? So I'm just going to erase this part and say how many 12-ounce bottles equals 768 ounces? Okay, now, this is how much total liquid I have. And I want to know if I'm pouring out 12-ounce bottles over and over and over, or I'm repeatedly subtracting 12, how many bottles would I need? So now I'm actually going to divide. So I have 768 divided by 12, okay? Let me get a different color. All right, 12 goes into 7. That's not going to work, but 12 goes into 76 6 times, okay? 6 times 2 is 12. 6 times 1 is 6 plus 1 is 7, okay? And then I'm going to subtract. So I have 4, and then I bring down that 8. 12 goes into 48 4 times. 12 times 4 is 48 with no remainder left over. So it would take 64 12-ounce bottles to equal that 768 fluid ounces, okay? So 64 is that one. Number 2 for Tuesday, Sally bought 4.5 pounds of potatoes at the store. She used 3 1/5 pounds of potatoes to make soup. How many pounds of potatoes does she have left? So first of all, we're going to subtract, but this problem is kind of funny to me. I wrote this problem a long time ago, and honest to goodness, I am making potato soup at my house. Well, me and Mr. Dowell-Young are. It's in the crock pot right now. There he is. So I did not plan to do it on the day that I did this video. It just kind of worked out. So it's a little bit creepy. And here I'm talking about potato soup in a problem I wrote a long time ago. So weird. Anyway, okay, so she bought this much. She's going to use this much. We want to know how much she has left. So we are going to subtract. When I subtract, I'm going to think about I want a common denominator. So I'm going to use the 4 square method. And I'm looking for the least common multiple. Okay, so I'm going to list the multiples of my denominators. Just trying to fix that glare. So I have 2. I'm going to count by 2's or list the multiples of 2. That would be 2, 4, 6, 8, 10. I could keep going. I just ran out of room for right now. And then I'm going to list the multiples of 5 over here. So I have 5, 10, 15. But I can already see that the least common multiple, the common denominator, is going to be 10. Okay, I know there's a glare, but you can kind of see it a little bit there. Okay, so 10 is going to be my denominator. So when I rewrite my fractions, I'm going to have 10 as the denominator. Okay, I've said this in a lot of my videos, but in case you didn't watch one of those, maybe you made 100 on that quiz, just remember, I think the most common mistake I see with adding and subtracting fractions, people do this great, they get a least common denominator, everything's beautiful, and then they forget about the poor little numerators, and they just keep them the same, which is not fair if you're changing the denominator. If I'm multiplying the denominator, I need to multiply the numerator. So 2 times 5 is how I got to 10. So I'm going to say 1 times 5, and my numerator is going to be 5 on this first fraction. And then you can kind of check it. I know that 1/2 is equivalent to 5/10. So I didn't change the value. I'm just representing it with tenths instead of halves, okay? Then the same thing over here. 5 times 2 is 10. So then, because that's how I got this, so then 1 times 2 is 2. And then I can just subtract. 4 minus 3 is 1. 5 minus 2 is 3. And then 10 is going to stay the same. So she's going to have 1 3/10 pounds of potatoes left over after she makes the soup. Okay, Wednesday, number 1, more soup. I think this one's about soup. Okay, Wednesday, number 1, Amy needs 3 liters of soup. Okay, she needs 3 liters of soup. The soup comes in cans, my beautiful can, of 300 milliliters each. How many cans should she buy so that she has exactly 3 liters of soup? You can do this problem a couple of different ways, but the problem is I have liters here and I have milliliters here. So she needs this amount of liters. She has cans in milliliters. We have to make those units match. So you could convert milliliters to liters or liters to milliliters. I converted liters to milliliters. And to do that, I'm going to think of King Henry. Remember, King Henry died by drinking chocolate milk. Poor thing. Poor guy. Okay, I have 3 liters. Liters is my base. There's no prefix before it. Okay, so I have 3 liters. I'm going to convert to milliliters. Here's milliliters. So I'm going to move 1, 2, 3 places to the right. That means if there was a decimal here, I could move it 3 places to the right, or I'm really multiplying by 10 times 10 times 10. Okay, so 3 milliliters, or excuse me, 3 liters is the same thing as 3,000 milliliters. So I'm just going to rewrite my problem. I keep changing colors. So she needs 3,000 milliliters. Okay, now every can that she buys has 300 milliliters. So we want to know how many cans she needs. So basically we're saying 3,000 milliliters, and if each can holds 300 and we're seeing how many groups of 300, we're basically dividing. Now we can use Veronica. We've multiplied a lot with Veronica, and we've also done some division with Veronica. Every time I divide by a power of 10, I can take away a 0, as long as I do it to both numbers. So if I divide by 10 and take away this 0, I'm going to divide by 10 and take away this 0. If I divide by 10 and take away this 0, I divide by 10 and take away this 0. So I'm left with 30 divided by 3, which of course equals 10. Okay, so for that problem, it says how many cans should she buy. So it'd be 10 cans, like a tin can. Didn't plan that. That's pretty cool. Okay, number 2 for Wednesday says, what is the product of 96 and 5/10 times 2 and 54 hundredths? So this is how the problem would be written. Okay, we have 96 and means the decimal, 5/10, 2 and 54 hundredths. So first of all, just make sure you wrote the numbers correctly. I gave them to you in word form, and then I put them in standard form. So make sure you've got that correct. And then the product, is, of course, is the answer when I multiply. So I'm going to multiply those numbers. Remember, I don't have to line up the decimal. I don't have to add placeholders when I'm multiplying. You can, but then there's just going to be extra zeros floating around that can get a little confusing. You can do it, but you don't have to do that when you're multiplying, okay? 4 times 5 is 20. 4 times 6, 24. 26. 4 times 9, 36. 38. I need to estimate first. I forgot to do that. So if I round this up, that would be 97. And if I round this up, that would be 3. Okay, so it should be close to 291. It's not going to be super, super close, but it'll be pretty close. Okay, so then I'm going to add my first placeholder. 5 times 5 is 25. 5 times 6 is 30, 32. 5 times 9 is 45, 48. And I can add a placeholder here. There's a bunch of cars and people walking down the street. I wonder if they're like, what's happening? So I should put out a sign like free math lessons, come on in. Okay, so then if I move to the next digit, I'm moving one place to the left. I need to add a second placeholder. Don't forget that, okay? I need to add a second placeholder because I'm moving over one more place value position. 2 times 5 is 10. 2 times 6 is 12, plus 1 is 13. 2 times 9 is 18, plus 1 is 19, and then I can add some placeholders here as well. Okay, I'm going to take my partial products and I'm going to add those. I don't have room for my symbol, but I'm going to add those. So I have 0, 6, 7, 8, 9, 10, 11, 8, 9, 10, 11, 8, 9, 10, 11, 12, 13, 14, 15, 9, 10, 14, and then 2. Okay, now, based on my estimation, the decimal here, that's going to be 24,511. 2,451, 245, not super close, but definitely the closest so far. 24 or 2 or even just a big decimal number that has 0 whole numbers. So we can sort of see that the decimal is going to go here, but then remember to check what I would do. Oh, somebody's looking in the window or in the door. What I would do is after this decimal, there's 1 place. After this decimal, there's 2 places. So I have 3 total spots that should be after my decimal. 1, 2, 3. Then I can erase this 0 or I can leave it. It's not really doing any good, but put your decimal first and then erase it, okay? So the product is 245 and 11 hundredths, or 110 thousandths if you think of it that way. All right, Thursday number 1 says put the following numbers in order from least to greatest. And so I have these numbers. Now remember, when I'm ordering numbers, I want to line up all the digits and I want to line up the decimals. More people were looking in, and it was a little kid. I should be like, are you in 5th grade? Come on in. Okay, I'm not creepy at all. Okay, so sorry, I get a little distracted. Okay, so I've got all my ones places lined up. Be careful, I feel like this one might have tricked you. This is 1 whole, okay? So even though it's the shortest as far as the number of digits, it's still in the ones place. It's still a whole number, so it's going to go here. And then I could put a decimal afterwards. And then I'm just going to fill in everything else with a 0. So I've got my tenths places lined up. I've got my hundredths places lined up. And then I've got my thousandths places lined up, okay? So we're ordering from least to greatest, so smallest to largest. If I look over here on the left, I'm always going to start on the left. Obviously, this is going to be my largest number, so I'm going to go ahead and put it over here at the end. I don't know how much room I'm going to need, but it's my largest, so I'm going to take it out of the equation. Okay, so then I have 0, 0, 0, 0. They're all tied. I'll look 1 more place over, so I'm going to look at the tenths place. I have 1, 2, 0, 4. Obviously, 0 is the smallest, so I have this number. I think there wasn't a 0 at the end originally. It doesn't really matter. Okay, I look again at the tenths place. 1, 2, 4. 1 is going to be my next smallest. Let's see. Okay, then I have 2 versus 4. Okay, and then, all right, so there we go. That's least to greatest. Looks a little wonky. I just realized that was glaring, but you're going to have 7 hundredths first, then 135 thousandths, 26 hundredths, 4 tenths, and then 1 whole to go from least to greatest. And then the last one, Thursday number 2, says the rule is 2x equals y. Fill in the missing numbers. Why? I don't know. I'm just kidding. Okay. I'm a little hyper, I think. Mr. Dowell-Young's laughing at me. It's okay. All right, so really we've got 2 patterns going on. We have a pattern in the x values and a pattern in the y values. So you could actually find the missing numbers that way. I can see here that I'm adding 1 each time. 4, 5, 6, 7. And then in the y column, I'm adding 2 each time. 8, 10, 12, 14. So your missing numbers are 7 and 14. What this means is that whatever the value of x is, I could plug it in, I could fill it in here. And then if I have those numbers beside of each other with no operation, so kind of like this, remember that means to multiply. So that just means that 2 times whatever x is would equal y. If my x is 4, 2 times 4 equals my y of 8. If my x is 5, 2 times 5 equals 10 as my y. So on and so forth until we get to the one we just filled in. 2 times 7, my x, is 14, my y.